So here's where we get to see whether I can still remember anything about three-phase power. That's what I actually started out in about 25 years ago. I have got my, my right-hand man, Mr. Sirawat P. I still can't pronounce his surname even after working with him for more than 10 years, but he's my foremost legend when it comes to three-phase power systems. So if you want to get into he's almost got a doctorate in three-phase after spending his entire life doing it. So he will be here to join me as well. But, let me find this clicker. All right, so what I'm going to do is I'm going to talk to you a little bit about innovation in three-phase, and particularly also bringing in some of the new energy storage technologies, which we're starting to see come well and truly into the critical power space. So I'm going to start with a little bit of voice of customer-led R&D. So one of the things that Schneider do really well is before we develop new technologies, we actually go and talk to our customers and say, well, hey, what do you think of this? You know, what are your challenges? What would you like to see us bring into the space? And this particular piece of R&D that we've done around here, I think is, if you look at the origins of Schneider's UPS business, you had the Danish contingent with the original Silicon technology, you had the MGE business, which was the French, and you had, for those of you who've seen the Symetra PX modular architectures, that was really more the American influence. And this is the first time they've really come together under one roof and designed something that will be the basis of a lot of our architectures moving forward. The technologies you're going to see here are available right now in the medium to large space, and they'll come down a little bit in the future. So I'll talk a little bit about that R&D just very quickly. I'll introduce a bit more depth that concept of e-conversion that I touched on this morning, and that's focusing in on that energy hog in the data center. I'll talk about the next generation of inverter technology that's in there, give you a little bit of insight into what that's doing in terms of efficiency and reliability. And then I will get into how we're making life a little bit easier around the install, testing and scalability, and then close off with a little bit on the lithium-ion storage technology. And the great thing is, today we've actually got one of these machines out there. We haven't got the lithium on display as well, but we have actually got this technology out there, and you will be able to see the e-conversion process in complete with scope meter waveforms and everything to prove that I'm not just up here saying that it's a great technology. All right, so if we look at this voice of customer, we did this a couple of years back, and we went to the industry and we said, you know, what are the big rocks in the data center world that you'd like to see come into critical power systems, and how can we improve them now, because we're at the drawing board stage with our next generation. So one of the things we always struggle with in the data center industry is capacity planning. So knowing exactly what that rack density is going to be, how much demand will you need, how much will you need in the future, how can you scale to it, and how can we get it matched to the IT load rather than dramatically over-provisioning, which ties up a lot of capital, and also lightly loaded machines are typically not efficient as well. So, and planning, uncertain demand for planning and density. Reducing energy consumption, I think you've seen a lot of strong undertones around the need to do more of that. Increasing availability expectations, so there's only one thing that's happening in the data center world is that our tolerance for downtime is reducing. Increased service life. So particularly in the commercial data center operator world, we don't want to be replacing machines every 7 to 10 years. They're looking to try and prolong this, and they're looking to try and get to be able to use those assets for longer. Simplifying testing, making things easier and faster to deploy, and improving safety. And for Schneider, safety is always absolutely paramount in everything that we do. So that was some of the feedback. There's about 50 different things that came back, but those were the top ones that came in, and we've tried to bring all of that into this new product line. So let's talk a little bit about how e-conversion works. And this will be a little bit technical, but I'll try and, I can see I've got quite a mixed audience here, so I'll sort of try and get it in the middle. So in order to understand how e-conversion works, let's just recap on how double conversion UPS works. So in essence, you have a rectifier, you have an inverter, and you have, these days, a DC to DC converter sitting down the bottom, charging and taking bidirectional flow in and out of the battery. So in normal operation, power flows in, goes through the rectifier, is inverted, so it goes through the rectifier onto the DC bus, charges the battery, and then if there's an outback through the inverter, and then if there's a mains failure, then we fire over and draw power out of the battery. So that's how that double conversion UPS has worked for a long time, right? So you get very high quality power on the output, you've got input power factor correction, you've got good short circuit handling capability, and very importantly in the data center world, class 1 voltage regulation, which means that you don't have any break in the output, output, and you've got a nice output there. These days, with the absolute best cream of the crop, we can get 96% efficiency with the current 3-level technology that I'll show you in a little bit. And then there was eco mode, and this was meant to be the saviour in terms of energy efficiency because it drove the efficiency right up to 99%. The problem with eco mode though is you're essentially sitting in bypass, so you've got that power flowing in rather than going through the rectifier and through that double conversion process. You've got it going in through the static switch, you've got it coming out to the load, and then there's a changeover if you have a disturbance. And the challenge with that is there's a break in the output, doesn't comply with class 1 voltage, and has really not been used in the data centre industry much at all, right? Used quite a bit in emergency lighting applications and those types of things. No power factor correction, no harmonic correction, and a lot of the challenges existing there. So what e-conversion does, it's about taking the best of both worlds. So essentially, if we look at our UPS architecture again, we do use that bypass input. So in through the top, through that AC line, through the dotted line, in comes our power, goes out to our load. And here's where it gets interesting. So the way this thing basically works, it's like a big set of noise cancelling headphones. And if you've been on a plane, you'll know the way those things work. They take in the noise and then they inject an anti-phase noise in there to cancel that out. Same principle applies here. So you've got the inverter, which is now a bidirectional converter, injecting anti-phase current into that load in order to cancel that out. And what that does, gives you nice clean input current, nice clean input voltage, in phase, power factor corrected, right? Then if there's a failure of the mains or it drops outside of a certain tolerance, then what will happen when we get that failure scenario, power will flow out of our battery, through our rectifier, through our inverter, which was already running anyway, and it takes over. Now here's where it gets really interesting because there's quite a few patents that we've got floating around inside this technology. And what it basically does, it has to be able to operate the static switch really, really quickly so we get no break in the output. And there's a patent around that, and they won't even tell me how it works, right? But what it will do is it will quickly open and stop power flowing back into the grid and trying to regulate all of downtown Sydney, because that's not a good thing to do. So there's a lot of technology going into there. So that's the first piece, that's the first party trick that this thing can do. All right, and you'll see that outside. We're actually demonstrating a transition from e-conversion mode to battery operation. Scope meters out there, you'll see there's no break in the output. So it's not, don't just take it from me, go and see for yourself. So let's talk into the actual inverter because there's a lot of technology gone in here as well. And when I started in the industry, we had transformer-based UPSs and the efficiency of a UPS was probably 85%. Then a little while later came along we removed the transformer out of them. We started to up the battery bus voltages in there. We got rid of that transformer. And our inverter was essentially two devices like you see there in the orange circle. So you've got two devices and you're switching your full 900 volts and you're stepping and producing a waveform, which is then, that waveform is pulse width modulated and goes through a filter to produce a nice output sine wave. And that's the way pulse width modulation works and produces a sine wave. Challenge with this is you've got 1200 volt devices sitting in there, you've got 900 volts and they're working pretty hard. So it's a bit like my maximum heart rate is 170 or 180 or whatever it is for my age, but I'm constantly running at 3/4 of that. So I'm wearing out a little bit. So we want to try and get the heart rate of the system down. So along comes 3-level switching, and we actually were the first to bring this to market, but the whole market pretty much does 3-level switching now. So you've got another combination of devices in there, and this time what you're doing is introducing an additional step in the process. Same thing, but now we've got a reduction in switching voltages. We're down now at 450, right? Now this one doesn't actually, because typically those devices are 600 volt, we don't end up actually doing a lot about, with 3-level, we don't do a whole lot about the actual heart rate of the unit, but what we are doing with that is reducing the switching losses, right? And that's where we get from that sort of 10% losses down to 5% losses in the inverter by going to this 3-level switching, right? So all of the Schneider products that you're used to across our range currently using 3-level switching, and most of our competitors using that as well. The 4-level inverter that's in the V-series machine that you see outside, here what we do is we put an additional switching step in, and now we're getting that switching voltage down again. You can see the step waveform up the top there, and we're going down to 300 volts. Now, switching now has the losses in that device are substantially reduced as a result, and we're actually starting to dissipate a lot less energy. So at full load, we're saving 1.5 points. But at light load, we're actually getting some substantial gains, even when we're running in this double conversion mode of operation without even using the E-conversion process. So here we compare the current generation UPS, which is the 3-level system, with the new 4-level. So you can see at 100% load, 95% efficient for a 3-level, 96.2 for the 4-level, right? But where it makes a real difference is actually down in this part. So this graph here shows across the bottom percentage loading on the UPS, and then up the side is the efficiency. And you can see that particularly in data center applications where we're operating with high redundancy levels, so we're typically producing 2N architectures with dual bus arrangements, and then particularly during the start of the life of a data center where it's not uncommon to see UPSs really running down in this very low end part of the curve. And that's where we're getting a full 5% or better improvement. So there's a real focus in on that low level thing. Again, as I said earlier this morning, this is all Energy Star data off the Energy Star website, and it does some comparisons on that graph there against our other machines and against some of the other units that are on the market as well. I'm not going to spend too much time on this one here because it's quite hard to explain in the time that I've got. But what this basically does is show the difference between and this is out of a power electronics study, and I can't hardly remember the stuff from university. It's a long time ago. But in a nutshell, what you're doing now is you're creating a lot less voltage stress on the device. So the real failure mode, almost like the MTBF, is substantially improved because you have a lot less voltage stress on the device. And I started out as a field service engineer, and back in those days, I had a lot of things blow up in my face. These days things have got more reliable, but the Achilles heel of a big UPS has always been the inverter and the batteries. So this is a significant improvement in addressing the reliability in these devices. So let's take a little bit of a look at efficiency comparison. So if we go to this is our losses in our UPS power system, and this is at full load. It gets even more aggressively improvements as we're operating more lightly loaded. So our typical double conversion 2-level inverter, 10% losses at full load, more than that down at the bottom end. The yellow bar is our newer double conversion. That's our 3-level, that most of what Schneider makes. Competitively, some people sit in that bucket A, some sit in bucket B, and there is quite a bit of variance in there. But that's typical. That's best in class, really, that 5% losses. And then with the 4-level inverter that I just showed you, then we get about another 1.5 improvement at full load. E-conversion, we get down to that 1.5% losses in the system, right, while still maintaining that class 1 voltage. And then eco mode, which I said not reliable over there, there's only a very minor gain. So when you're starting to talk about efficiencies like this, it kind of kills the argument that a DC-based data center is going to be more efficient and all that kind of thing, because you're running with such massive efficiencies in your AC-based system. So if we look at the 3-level when lightly loaded, then most of them would go up to about 9.5% losses down at that 25% load. And you can see that in the 4-level, again, it's only a very minor change there. So quite a significant jump in that area. I won't spend too much time on this. It's also got a really nifty party trick where because of the design of the unit, it actually you can load test itself without connecting up load banks. So what it can do is it can take 10% input current while still supporting the load on bypass, and actually bring the current in and actually run the machine up to full load by circulating the current. So we've got 160 kVA UPS sitting out there, and with that little piece of wet string that's hanging down from the ceiling in the Hilton there, we've had that thing running there at full load. Now, most UPSs running at full load in that environment, it'd be howling like a banshee, all right? So that's quite a nifty little party trick that it's got as well. So currently three frame sizes in essence. You've got your 200 kVA I/O, you've got your 1000 kVA I/O, and then your big 1500 kVA or 1.5 meg I/O. So you basically have your power frame connections in there. And in the case of most of these, what you can actually do is you can put the power frame and bus barring arrangement in to start with, because often when we're building data centers from scratch, we end up in a situation where we have to bring things in while the environment is less than ideal, right? Because it's still a construction site and there's a lot of dust around. So we can keep all the power electronics safely wrapped up and out of the way, so we're not doing that. And we can even power up, in most cases, through this arrangement. There's a lot of safety stuff gone into it. I won't spend too much time on that, but the way it's been set up for field service technicians to make their life easier, all that kind of thing. So let's have a look at lithium-ion technology now. So this, I believe, is honestly the real next big thing in the data center industry. 40 to 60% less footprint, 2 to 3 times the expected life, 60 to 70% less weight, 10 times the number of cycles when compared with valve-regulated lead-acid technology. Much higher operating temperatures, so you can run the stuff up to 40 degrees. It opens up a lot more free cooling options for batteries and that kind of thing. You wouldn't want to leave it at 40 degrees all the time, but much better temperature tolerance than lead acid. So a lot more options around it, saving energy in battery rooms and things. And 2 to 3 hour battery recharge rather than 8 to 10. So the battery is recharged, ready to protect the load much sooner than a conventional lead acid battery. 2.2 times initial capex, although that number's coming down every day, and some of the numbers are really impressive. And what we're talking about now is potentially a battery that'll last as long as the UPS. So in the big three-phase world, typically we would have been replacing batteries 5 years, 7 years. Maybe you had a really good out of your 10-year design life battery and got 8 years out of it. You know, unfortunately, most of them are in that 5 to 8, and they're all, no matter which brands you use, they're all pretty much consistently bad in that respect. And here, this lithium stuff is designed for 20-plus design life. So real-world service, you can expect to see better than 10 years, and we'll even put a 10-year full replacement warranty on them, which is quite unique. Also, very predictable in their failure modes. Compared to lead acid, which you can get some very random failures. So addressing the elephant in the room for a minute. All right, everyone's had that scare tactic. There's that fabulous marketing campaign on every aircraft about lithium-ion batteries. If you've got one, don't come on this plane with Galaxy Note, blah, 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 blah. This is automotive technology, all right? This is not your standard cheap lithium stuff. It's different chemical composition, a whole pile of the safety and everything is totally different. I'll show you that in a second briefly, but I put it to you that we've been using this, and these are actually the BMW i30 cells that we use in there, right? They literally are. And I put it to you, you're prepared to drive down the freeway at 100 kilometres per hour with your 2 kids in their car seats sitting in the back seat on top of the battery and achieve a 5-star ANCAP safety rating, then probably with what I show you next as well, you can have confidence that this stuff is safe. So these guys, that the battery manufacturer, they throw the kitchen sink at it, right? Internal short circuits, overloads, discharge, thermal shocks, thermal stability. They bake it in an oven at 890 degrees C and it has to be able to handle all that stuff, right? Then when they're finished doing that, they do low pressure tests on it, they immerse it in water, they drop it, they stab it, they crush it, they vibrate it with no flame, no fire, no explosion. That's the kind of rigor that goes around. So that's the cell composition itself. We go one step further. We take it, the cell itself has got a huge amount of protective mechanism. The module that they're connected together in has a next level of protective mechanism. Then at the rack level, there's a full-blown battery management system that's built in with the lithium ion, not a battery monitoring system, which is that typical monitor the voltage of the of the battery. This thing's a battery management system. It's able to look at individual batteries and cells and triage things and make sure you get optimum life out of it and provide a lot of intelligence, including communicating with the UPS. So the new generation of UPSs have this firmware capability to talk to this device and actually be able to completely inhibit charging if there was something in the other 27,000 levels of protection had been breached. So rings of defence around it. So summary, top 3 game changers, the e-conversion up to 99% efficiency with class 1 voltage regulation, 70% less losses, $60,000 to $100,000 per 10 years per 200 kVA. Right, so if you've got a 1 meg UPS, 5 times that number against the best competitive unit. Against the worst, it'd be probably like $1 million saving against some of the stuff. So some of these old units that you're seeing out there that are in places, the efficiency gain is just absolutely massive. 4-level inverter, even if you don't use e-conversion, in 4-level mode, you're going to be getting some significant gains. And we've got a great customer testimonial we're going to be able to share soon that's put them in 3 months. He's just going, whoa, because he ripped out a bunch of old units and put them in. And the lithium-ion battery, vastly improving that battery life, increased reliability, and space and weight improvement. We can't officially publish all the patents and things, but there's a lot of patents around that are approved in most countries around things like the 4-level switching, the way we control the static switch and all those kind of things as well. So we've got a pretty unique set of technology set here that we reckon is going to deliver a massive game-changing advantage to the industry in terms of energy saving. And that is what I had. Thank you very much. As I said, out on the stand there is a 160 kVA machine. Go and have a look at it, see the change of the waveform and that kind of thing.
A curiosity question.
Yeah.
How long does it take just to change over between a mains swap out and back up? 10 seconds?
There's no break. If you go and have a look, you'll see. We'll do that test on the stand there for you. We'll run an e-conversion. We'll drop the mains. It'll transition to battery, and you can see the scope meter. There's no break. Zero gap. It's class 1. 0 gap. Yeah. Yeah, and an engineer from 25 years ago that's now a GM, you might not trust me, so that's why I put the scope meter out there.
The conversion UPS.
Yeah.
You said it stays on the static switch.
Yes, and if you're in e-conversion mode, yeah.
The double conversion acts, I presume, as an active filter. Is that correct?
In essence, yes, yeah, and that's not completely unique. What is really unique is the 4-level and that control of the static switch. Active filters have been that kind of active filtering in a bidirectional converter has been around for a while, but you couldn't make that transition from the e-conversion mode into that mode of operation without a break. So the competitive stuff's class 3 voltage and not able to do data center grade protection.
The batteries, the lithium-ion
Yep.
batteries, lead acids are quite temperature sensitive and affects their life
Yes.
quite drastically if you do higher the temperature. What is the temperature sensitivity of the lithium-ions?
Far less. I can get you to the data, but if you, for example, were going to use pure free cooling and basically no mechanical cooling, you might be able to, depending on where you are in Australia, you might actually be able to get away with it, right? So it's what we've got. Sirawatt's got all the data, and I can't give you a black and white answer to that, but the whole process of the way they work and everything, it's that they're much more robust as it relates to temperature. So there's a few things. So the question was, can you just take lithium and put it on a normal UPS? A bit depends around the bus voltage of the UPS, but you also need the firmware to be able to. You need the right charging regime. You need to be able to display on the display and get it all right. And you need and really to get that fourth layer of software protection, if you like, then you need the UPS to be able to essentially inhibit its charge regime if it detected something wrong. So professionally, it should be done with and we'll be releasing, so some but not all of our current UPSs will be able to have, for example, the Galaxy 7000, we've released a firmware upgrade that we can do it. The PX250, for those of you who've got that will be able to have it. But some of the ones with lower bus voltages in the older generation won't. Yep.
Is there one life?
I'm pretty sure, and Sarah might be honest, I'm pretty sure there's just the one life expectancy, and it's 20 plus, right? But it's yeah. I mean, the cycle. It's part of it's that cycle count, right? Yeah, that's a big part of it. Yeah, I mean, NICADs or something like that might give it a nudge in essence. Yeah, but if you get, I mean, the fact that I'm prepared to give a 10-year warranty on that battery sort of gives you an idea on the confidence. I mean, they're pretty. I would have to check in that one. I'm not completely sure. They are more resilient, certainly. And the thing that with the battery management system, because one of the things with over discharge is when you start to recharge them again, you get different differential voltage across the series string, and then you start over and under charging, and that's what you can, when you're trying to bring in. The BMS system, full-blown battery management, so you're actually literally able to triage individual blocks and say that one needs to be, and so it's in blocks, I believe. Sarah, what? Is it blocks or cells? Sorry? I'll just ask my professor that question. Just we need to be a bit thrifty on time. That's also.
So if you can go back to one the slide that showed. Let me just.
Oh, it's gone.
Can we go back?
No, I don't think so. Maybe come and have a chat to Cyril Watt. This man knows more about UPSs and things than I don't know what. But so feel free to come and have a chat to him, and he will be able to. Yeah.
Because right, we just show you one photo of the lithium-ion battery rack, and within that rack has actually, if you count it, if you have time to count it, it is have 17 modules. Each module has 8 cells. So within that modules, right, we have 8 cells, and one cell is actually one block. But however, this system within one module is 8 cells, right? And that 8 cell is actually about 17 kilograms. So the cabinet that you just saw, that cabinet is just about 550 kilograms. So it's really light.
Yeah. And which, so just to answer the question though, what level are we able to take the battery management in terms of equalizing a block? Or?
No, because one cell is one block.
One cell.
Yeah, that's right. So that means within that cabinet, we have 136 cells, which is actually 136 blocks as well. So it is different from the lead acid battery. Lead acid batteries, one containers may have 1 cell, 3 cell, or 6 cells, right? And then if you run into 6 cell block batteries, typically you measure or you you monitor 6 cell, right? This one we monitor cell by cell because it's just 1 cell per block.
What's the voltage of each cell?
3.8 volt per cell. Yes. So that means that 136 cells, you're going to end up with approximately 500 something. Yes, which is that is a DC bus of Galaxy V series. Yeah. Yes?
How do you measure the state of charge? Do you calculate it, or do you measure voltage?
It is the combination of both, yes. We measure, because the keyword, right, is not battery monitor, it is battery management system. So this is the system that we also manage the performance of the battery as well. It's a proactive system that we have. In the normal installation that we have, right, if you run into or use lead acid nowadays, all the battery monitoring system that you have is just monitors, it's passive. It doesn't do anything.
There are systems where the system can switch to discharge, where it runs a routine to test a discharge rate and the voltage
That is per bank, and that is the characteristic of the UPS, right? But if you have another system called battery data logger, which is a per block monitoring, that is monitor. You don't really control anything. It's just a passive. Whatever happens, you just see it, right? This one within the lithium-ion battery system that we offer. Every cabinet comes with battery management system, which is we balance all the voltage to make sure that every.
Management system monitor just voltages and also monitor current as well to see.
Current as well, yes. Actually, we measure it at cell level, at modules level, at rack level, and at UPS level. Current, voltage, temperatures. Yes.
I'm just thinking I love questions, so I don't want to kill it, but I'm just conscious of the time because we've been having a time dilemma all day. Maybe if
we can take it offline.
Yeah. So Cyril Watson, he loves this stuff, so very passionate. He's been around in this game as long as I have. So thank you very much.